Alright, we're going to be looking, this is going to be our second set of notes for Unit 1. And our first topic that we're going to be looking at is measuring segments. Okay, so the distance between points A and B can be written as the length of that segment, or the length of segment AB. Now, similar to when we were writing lines, we talked about that symbol on top, and this would be the symbol for line. So this would be a symbol for segment, right? There's no arrows, so this is telling us that the segment is going to start and stop at a specific location, unlike a line where it continues on and on forever. Now, this curriculum that we use does allow you to write your segments, just erase that, does allow you to write it as without the symbols. Now, in some cases they are very important, so I would recommend just getting into the habit of using these symbols. Alright, so we can see for segment AB, it starts at -1 and stops at 4. So we can see that segment AB is 4 units. Alright, congruent segments. This is the symbol for congruent. I recommend writing it over here, that way you have it. If segment AB equals segment CD, in this example right here, we can see that A is 4, and AB is 4, and CD is 4. Then the segments are congruent. And the way we would write that is segment AB is congruent to segment CD. Okay. Now we're going to be talking about the segment addition postulate, and this is where we kind of get more into some algebra. Okay, nothing too hard, but just some things that we need to understand. It says that if A, B, and C, talking about these points here, are collinear points, right, on the same line, collinear, and B is between A and C, then we can say that AB, the segment AB, plus the segment BC equals that whole line, right, AC. Nothing too hard. So let's just say segment A to B was 1 unit, from B to C was 3 units, then we could say that A to C is 4 units. So here we have a few practice questions, and you guys could do these on your own for these number 1 and 2. But let's look at some more practical uses of how we might use this in geometry. So right here they tell us that EG, right here, EG is 71 units. So from here to here is 71. And they want us to solve for x. Well, we can solve for x by setting up an equation, right? If they told us that this was 5 and this was 15 and this one was 20, then we could say, oh, okay, yeah, the full length is going to be 35. But in this case, we're going to set up an equation where EF, my eraser, okay, EF plus FG equals EG. Okay, so let's plug in those values. So EF is going to be 8x minus 17. FG, we're going to bring down our plus sign. FG is 5x minus 3. Bring down our equal sign. And then EG, which is 71. So now we have an equation where we can solve for x. So let's combine our like terms. Right here we have -17 and -3, so we're going to be adding, and the answer is going to be negative. And then 8 plus 5x is going to be 13x. Let's bring down our 71. I'm going to bring up my answer over here so I have more space. So we have 13x minus 20 equals 71. Let's bring our 20 to the other side. So now we have 91 equals 13x. So we're going to take that 13 divided by 91, and x will be 7. Okay. Let's take a look at number 4, and this one, you're going to have to take a step further. So they tell us that TV, so what is TV? TV is this whole length, equals 14x minus 8. They say find TU, so they want to find the length from here to here, so we're going to put a question mark. Well, before we can find that length, T to U, we need to find our x value to plug it in to this 9x plus 2 to find that full length. So remember, TU plus UV is going to equal the whole length, TV. And TU, they give us a expression, so we have 9x plus 2, bring down that plus sign, plus UV, which is 5, equals TV. So that's going to be our 14x minus 8. And we need to solve for that x first. So we have 5 plus 2 is positive 7. Bring down my 9x equals 14x minus 8. I'm going to bring my 8 to the other side so I don't have to deal with negatives. So this is 15. I'm going to bring my 9 to this side, my 9x, and bring my equal sign down, of course. And now I have 5x equals 15. If we divide both sides by by 5, then we get x equals 3. Okay, so now we found our x, and now we still need to plug it back into this expression to find that length TU. So now I have 9x, or 9 times 3, plus 2 equals TU. 9 times 3 is 27. 27 plus 2 is 29. So we found out that the length of TU is 29 units. We're on the back side of this notes, the page, right? And we have another definition or topic we need to talk about. And it talks about the midpoint of a segment. Okay, so what is the midpoint? Let's talk about that. The midpoint of a segment is a point that divides the segment into two congruent lengths. And that makes sense. Mid means middle, point in the middle, so point in the middle of a segment. Makes sense. So we can see here, we have a point B on this line, on this segment AC. And these little tick marks, you're going to see these a lot in geometry. This basically is telling us that segment A to B is the same length of segment B to C. So if A to B was 5, then C to B would also be 5. Okay? So those tick marks are a great clue for us. And one thing that we can say, because B is in the middle, that is our midpoint, we can say that segment AB is congruent to segment BC because B is a midpoint. Alright, so next part. A line or ray or segment that intersects a segment at its midpoint is said to bisect. Bisect sounds a lot like to dissect, right? If we were to dissect an animal, maybe in biology, you would cut that animal in half, right? So bisect is a very similar version of that word. Okay, so if it's said to bisect, the segment is called a segment bisector. Oh, that looks pretty bad. Let me fix that. Okay. So if we look at this line right here, line L, it's cutting straight through this segment AC at the point B. And we've already established that point B is the midpoint. So line L is a segment bisector of AC. All right, so in the diagram to the left, point B is the midpoint of segment AC, and the line L is a segment bisector of segment AC. Okay, let's go ahead and look at a problem of how we might apply this information. Okay, we're only going to do one of these because there's nothing much to it. It's just mostly algebra and learning how to set up those problems. So if Q is the midpoint, so ding ding ding, I'm thinking midpoint. I know Q is going to make this side congruent to this side, so I'm going to write my tick mark sign so I know that PQ is congruent to QR. Find the value of x. If I say that PQ is congruent to QR because of that segment bisector, then I could say that 7x minus 16 equals 4x plus 2. Alright, I'm going to bring my 16 to the other side so I don't have to deal with those negatives. And I'm going to subtract 4x. It's an ugly 4. Okay, and so 3x equals 18. Divide both sides by 3. X equals 6.